Okay, so let's get started here. Looks like most people are ready to go. So with the exponential growth, we talked about what this whole thing meant, what this formula meant. We stopped here last time because I said it's a lot of information because we had that not emergency, but vaccination assembly that you guys had to go to. And so just the second thing I wanted to talk to you about it was things like half-life or something exponential decay, which is when the base of the power is smaller than one. So when we have a half, that would be half-life, and so that will be considered, less than, and so on and so forth. So when we work with this kind of thing here, when we work with like exponential decay, the formula is exactly the same. The only difference is that the base is one half. The representation of the variables and what they stand for are exactly the same, right? So when we look through like an example here, let's go through this example. Like a, a scuba diver knows that light intensity decreases by 2% each meter below the surface. And the function given is 0.98 to the power of n, where I naught is the initial amount of light. Now, why, if it says decreases by 2%, why do we use 0.98? What's the reason for that? Why is it 0.98?
Because they subtracted by two.
Yeah, exactly. From 100%, if we're decreasing by 2, that means we're getting 98% of light every time. And so that's why we use 0.98. And so that's why the base is there. And so it says he needs a minimum 60% of light to operate without the aid of additional light sources. Is he able to take pictures at a depth of 23 meters without the aid of additional light sources? So the initial amount of light at the surface, okay? And then he needs a minimum of 60% of light. Have you noticed that they didn't tell us what the initial amount was? In this situation, the initial amount can be anything. And we might as well set it something simple like 100, because if we're trying to find 60% of 100, it's just 60. So it makes our life a little bit easier. If I haven't given you an initial value, you can decide your initial value in these situations. And if you're ever confused, like you didn't give us an initial value, I'll clarify. Like on the test, you ask me a question, I'd be like, oh, don't worry about it. You can pick your initial value. I say 100, right? So whenever you have questions, always ask me on a test. But it tells us that n is going to equal 23, and we need to solve for I. So when you plug it into your formula, you would get 100 bracket 0.98 to the power of 23. And solving this on a calculator, you can just plug it in straight in on a calculator. 0.98 to the power of 23 times 100. And we get 62.
Mister, where did you got the 100 again?
You can pick that one, I said. I
Oh,
didn't,
okay.
so you can pick it. So we get 62.8 as our intensity, 23 meters down below the surface. Let's answer the question. Is this scuba diver able to take more pictures? Yes or no? The answer is yes. Okay. The answer is yes, because he needs at least 60% or more, and he has 62.8% or higher at 23 meters. So at 23 meters, he has 62.8% of light. So yes, he can take more pictures. That's the answer to the question. So the way you plug it in, as long as you write your givens, right? Givens, G, givens, unknowns, equation, substitute, solve. The guess method comes back every time, right? When it comes to word problems. So it doesn't change anything. And then I gave you the general formula for exponential decay. Of course, I will be giving you these formulas for your test. Okay. Are there any questions about growth and decay as we jump into our homework stuff and our review stuff? All right, so it looks like there's no questions there. So let's jump into 7.5a. Did you just want me to fill in this table? It was the table, this the one you want to talk about? Wow, thundering like crazy outside right now. Okay, so for this table, it says for figure 2, what's the value of y when x is 4? The value of y is 1,296. And if you have a scientific calculator that can do the fourth root, you can do the fourth root because x is 4, right? If you don't have a scientific calculator that can do the fourth root, you're going to have to do it yourself. So you do, I don't know, 5 to the power of 4. Oh, nope, that doesn't work. Okay, 6 to the power of 4. That works. So the base is 6, and so we would get f of x is equal to 6 to the power of x. There's not much else I can really say about this table. So you going through each one, like, oh, for figure 3, y is 6 at x equals 4, y is 16, and that would be 2 to the power of 4 would give me 16. So the base is 2. So my function would be f of x is equal to 2 to the power of x. And continuing onwards there. And then these ones in 4, 5, 6, we go into the decimals, which are a little bit harder by like trying to guess it, which I understand, right? It's a little bit harder, but you can definitely figure these out. This is 1/2 actually. If you have once again, if you can do the fourth root, then that will save you some time. Okay. If you don't have a fourth, like if you don't have a like different root calculator on your phone, like most phones don't have it, scientific calculators do, which is more reason to get a scientific calculator. So once again, if you have it on a scientific calculator, you should use it. If you don't, you should probably get one. And so when you kind of pump these out, you should be able to figure these out. So, wow, that thunder's really loud.
Mr. Choi, can we take up question 5 from the review?
Yes, we can. So for figures 1 to 3 and 4 to 6, so for 1 to 3, we can see that the b value is greater than 1 since the graphs are increasing. And then for figures 4 to 6, the value is between 0 and 1 since the graphs are decreasing. And so that's the difference between growth and decay. Those are the differences here. Okay.
Is it okay if I put equal sign? I can't hear you, Mr. Choi.
Where did you mean equal sign? Like put an equal sign where?
Figures 4 and 6.
Is equal to 0 and 1? No, between. Between would be the right word. Yeah.
Okay.
Yeah, between. So with that being said, I probably won't give you a question like this on the test. I'll be honest with you. I'd rather have you work through exponential laws and then a couple of growth and decay questions, and that's it. So that moves us on into our first piece of review. I believe it was
Wait,
this one
Mr.
that I
So
uploaded.
all of the word problems are just like what you just took up?
Yeah, like from like 7.6, 7.7, growth and
Yeah.
decay. That's it. Those
Okay.
are the only word problems that kind of come out of it. Yeah. Okay. So exponential laws, right? When you multiply powers, you add the exponents. When you divide powers, you subtract the exponents. When you have a power of a power, you multiply the exponents, right? Anything to the power of 0 is
1.
1.
1. Very good. Anything to the power of 0 is 1. And of course, anything to a negative power, I said think of the negative as an item. You use it, and it flips the base fraction, right? It flips the base, whatever the fraction is. So you use the negatives at the very end. Do not use the negatives at the beginning. And that's what's going to screw people over. If you do it at the beginning, it makes no sense. Okay? So for example, for question 1 here, right? We have 2 to the power of 2. Oh, I got to replug in my stupid tablet. All right. So we have 2m squared times 2m cubed. First, numbers multiply with numbers. 2 times 2 is 4. Get that out of the way. Then work with m. You copy the m down because the base is going to be the same. And then it's multiplying, so which means the exponents add. So 2 plus 3 is 5. Same thing happens to the next one. 1 times 2 is 2. We copy the m. 4 plus negative 3 is 1. Or we don't really write the 1, we just write 2m. Okay? That's all there is to it with adding and subtracting exponents through exponent laws. If we look at question number 6, for example, here, numbers with numbers first. 2 times 2 is 4. Then write x. 3 plus negative 1. Oh, that's 2. And then for y, negative 3 plus 3. Oh, that's 0. Oh, wait a second. Y to the power of 0 means it's just 1, which means it disappears. And so write one more step. We don't keep it at y to the 0. We change it, right? We change it to the power of 0. Okay. So we'll do one more and then we'll go into, I think Franz had 2 specific questions from here. So question 10, for example, or no, question 8, for example, here. 4 times 1 is 4. We get the number out of the way. We see a v, so I'm going to copy the v down. 3 times, if there's no exponent, it's 1. So 3 plus 1 is going to be 4. And then there's no u here, but there's a u here, which means you just copy it down. So it's just u squared. And that's it. Okay. Any questions so far? Hopefully the adding rules isn't too bad. Subtracting rules aren't too bad. Yes.
Can you do 15?
So 12, 15, and 20, 26? Sure. So for question 12 here, we have 2x squared to the power of negative 4. So first, we're going to multiply these in, and when these multiply to everything. So we're going to get here 2 to the power of negative 4, and then we're going to get x to the power of negative 8, because they multiply. Power of powers multiply. Then what happens? Well, what does the negative do? Oh, it flips the base of each power. So we're going to get 1/2 to the power of 4 times 1 over x to the power of 8. And then we continue onwards here. 1/2 to the power of 4. Oh, that's 1 over 2 to the power of 4. And if you don't want to do this part, you can go straight into it. Oh, I know that's 1 over 16. And for this one here, it's multiplied by 1 over x to the power of 8. And this can be simplified into 1 over 16, x to the power of 8. Just like that.
Mr. Choi, I have a question. Would you
Yes.
want us to show all our work while we do this? Like, will we get marks off if we don't show our work?
So if you want me to show you the minimum for full marks here, if you did here, if you got to here, and then you showed me this, I'm okay with that. This is fine. I want to see that you've multiplied it and then transformed it into the final form. So you will have to show like one step in between. And then if I were to show just a little more work, I would see like this and into the final answer. This is okay too. Does that help clarify how much work I'm kind of looking for?
Yes, thank you.
Okay, no problem. Question 15 was the next one. So we have 3k to the 4 to the power of 4. So once again, that applies to everything inside the bracket. We're going to get 3 to the power of 4 and then k to the power of 4. 3 to the power of 4 is going to give us 81. Oh, sorry, not k to the power of 4. K to the power of 16. Whoopsies. 4 times 4 is 16. And then 3 to the power of 4 is 81. And then k to the power of 16 would be the final answer. 11 and 13 were asked just now, so we'll do that as well. 11's really easy. X squared to the power of 0. Well, anything to the power of 0 is 1. So that's 1. 13, although, is the 0 is only attached to the r. So this one happens a little bit differently. We still multiply this power inside. We get 4 to the power of 4, and then r to the power of 0. And so the r disappears because r to the power of 0 is 1. So we're left with just 256 with no variable because r to the power of 0 is 1.
Mr. For number 16, do you still have to flip the thing because it's negative, or just multiply?
Yeah, so in this case, do we have to multiply this in? Mike, that's my question to the whole class. Do I have to multiply this in? Yes or no?
You do still, right?
We don't. And the reason why we don't have to is because it's to the power of 1. When anything to the power of 1 is itself, right? Nothing happens. Like if I say, oh, 2 to the power of 1, what's that? It's 2. So when it's to the power of 1, all you have to do is use the negative. And so this just turns and flips everything upside down. That's it. That's what happens when it's to the power of negative 1.
Mister,
Yes.
for number 15, how did you get 81?
3 to the power of 4.
Okay. Right.
Because 1 times 4 is 4, and then 3 to the power of 4 is 81.
Okay.
So does that make sense with the negative 1 there, everybody? Right? So if it's to the power of negative 1, because something to the power of 1 is itself, the only thing that actually does something is the negative there. And it just flips everything, the whole base, and we get 1 over 4xy. All right. Then we had someone ask question 26. So let's go down to 26 here. So for question 26, yes, the more complicated ones here. These ones here, when you solve these ones, go one step at a time. Okay, so 2 divided by 3, don't change that. Keep that as a fraction. 2 over 3, you leave that at the front. And then we do each one separately. We write our x. 4 minus 2, because it's dividing, is going to be 2. Negative 4 minus negative 3 is going to give me negative 1. And then z to the negative 3 minus 4 is going to give me z to the negative 7. That's just integer math. Make sure you're doing that correctly when you subtract these numbers. 4 minus 2 is 2. Negative 4 minus negative 3 is negative 1. Negative 3 minus 4 is negative 7. Okay? Now from here, some of you might be, okay, now I don't know where to put these things. So notice how we have a fraction here in the front, right? The 2 over 3, we haven't touched that. We can't really touch it. So what you do, any variable with a positive exponent goes in the numerator because it doesn't flip. It goes on top. Anything with a negative numerator goes on the denominator because it should flip. So your final answer here, without the negative exponents, should be 2x squared over 3y z to the 7. And that would be your final answer. Because y is negative, z has a negative, so they go into the denominator, the bottom.
So negative exponents always have to go to the denominator.
Yeah, when they're like this, they go to the denominator of the fraction.
You
Right.
multiplied it, right, mister? Like to get
What,
the 7.
multiply what?
Negative 1
No,
and
I
negative.
subtracted because it's division. Negative 3 minus 4 is negative 7.
Okay.
Division is subtraction, yeah. So if we go for, like, for example, question, let's say 28, for example. Once again, numbers first, 2 over 3, rewrite that. And then h, oh, there's no other h's, so it just stays. J, negative 3 minus 1 is going to be negative 4. And then k is 4 minus 1, which is 3. Positives go on top, so we're going to get 2h cubed k cubed divided by 3j to the 4. Because j was negative 4, so it goes to the bottom. And that's the idea. You don't use those negatives until you finished simplifying everything, and then get rid of the negatives. Don't get rid of the negatives at the beginning. Get rid of it at the very end. Okay?
Mr.
Any
Choi,
other questions? Yes.
Will there be any like graphing questions on the test?
Will there be any graphing questions? Hold on. Let me see what I've built so far for the test here real quick. Let me remind myself what I have here. Are there any graphing questions?
Because there are like questions from the worksheet, like the graphing thingy, and the supply didn't really explain like what should we do on it.
There are no graphing questions, but there are there's like ones where like I'll give you a graph and I'd be like, which equation matches which, but you don't have to graph it yourself. Yeah. So there's that. So word problems, exponential laws, identifying functions, and that's it. That's all you have to worry about. Okay. Any other questions from the properties?
This is not how they do properties, but by identifying functions, do you mean like the difference tables and stuff like that?
There may be one about the difference tables, or like I said, if I give you a graph, if I give you like a graph containing 4 exponential functions graphed out, I'd be like, hey, which equation matches which one? And you should be able to figure that one out. It's not going to be like overly complicated.
Mister, if there are no negatives in the thing, like in your final answer, you don't have to put it in the numerator and the denominator, right?
Well, if they're all positive, then they should all go in the numerator.
Okay.
Yeah. All right. Any other final questions before we move on? Okay, looks like we're good. So we're going to move on into our review, our part 1. Okay, so for part 1, the questions that I got was question 1 and 2 here. Okay. These were radical exponents, all this kind of stuff. Is it going to be as complicated as this? No, I promise you it won't be. But this does go over some important theories that I do want you to remember. So for example here, just because they're fraction exponents doesn't change anything. This, I'm going to zoom in, 11 to the power of negative 10 over 3 times 11 to the power of 3 over 4. That's just 11 to the power of negative 10 over 3 plus 3 over 4. So all it's asking you to do is, hey, can you do fraction math? So what do you do for fraction math? You find out what's the lowest common denominator, multiply it out. So I'm going to get like negative 40 over 12 plus 9 over 12. And what that's going to give me is going to be 11 to the power of negative 31 over 12. Right? So it's still the same exponent laws. The only hard part that comes from this is, oh gosh, I have to do fractions. Which sucks. I'm not saying it doesn't. It does suck. But it happens. And you do have to know it. Okay? Same goes for these ones here. Like, I'm not going to make it as complicated as this, I promise you. If you did these properly, that's great. That's exactly what you should be doing. But let's take a look at question C. Question C is fair game. This is not overly complicated. It looks overly complicated, but the first thing you want to do is change the root function back into an exponent. So the root is going to change. Instead, we're going to write it like this. And what's the exponent? If it's the fifth root, what's the exponent that we change it to? If it is the fifth root, what do we change it to? What's the exponent?
5.
1 over 5.
Mm.
1 over 5. So make sure, like, square root is 1/2, cube third root 1/3, fourth root 1/4. So fifth root is going to be 1/5, so 1 over 5. And we can just do the integer math inside, the exponential laws inside. So we're going to get negative 6 times 3 is going to be 6 to the power of negative 18. And then the bottom here we can do separately. Negative 9 divided by negative 4, which is subtraction. So negative 9 minus negative 4 gives us 6 to the power of negative 5 to the power of 1 over 5. We continue onwards here. We do this math. 6 to the power of negative 18 divided by 6 to the power of negative 5 is subtraction. So negative 18 minus negative 5 gives us 6 to the power of negative 13 to the power of 1 over 5. And then power of a power, multiply, which just gives you negative 13 over 5. And that would be your final answer. So notice how we leave that power of a power on the outside at the very end. We simplify everything inside the bracket first, just like we would do in BEDMAS, and then do the last exponent, right? We do all of the laws on the inside, and that's how you would get your final simplified answer.
Mr. Choi, could you post more review after?
Can I post more review after?
Yeah, like, or like,
if you haven't tried the textbook questions, I highly suggest those. I personally don't have any more worksheets that I've personally have or created for it. I suggest going into the textbook and trying the practice test there if you haven't done so. Otherwise, that is the majority of it.
Mister,
Yes.
I have a question about the test. So, actually, I can print the test tomorrow because I've finished the ink from my printer. So, can I just write the answers for the test? Like,
You still have to show your work. You still have to somehow show your work on a separate piece of paper at least.
Yeah, okay.
Yeah. So that goes for anyone, like all students. I know some students aren't able to print in our class, so they've been writing out their answers on paper, right? And just writing the question numbers down. You're gonna have to do that, or else I won't know, right? So that's the minimum you got to do for me. Okay. Question number 2. An account is opened with $1,250 at a bank and pays 4.75% interest yearly. And so it says write a function that tells how much money is in the account after T years. And then don't graph it. I don't want you to graph it. But let's write the function down. Anyone know what interest is in math? We are going to be talking about it next unit as well. What does interest mean? If you're getting 4.75% interest, what does that mean? Anyone? Yeah, the money you make on your money. So it's extra money you're trying to accumulate. So do you remember the formula for like doubling? We said doubling time was like A is equal to A naught to the power times 2 to the power of T over D, right? Essentially. If that's the case here for doubling time, we can argue that for any rate of increase, that would be the same formula. It doesn't have to be doubling, it could be tripling. It could be I'm getting 50% more, I'm getting 25% more, right? It's going to be the same thing. Now, the one thing you have to realize, though, is that this is not, you don't use 0.0475 as the decimal. That would be wrong. How much? What is the decimal for 100%? It's 1. So if the decimal for 100% is 1 and interest is adding on to how much you currently have, we need 100% of your money plus 4.75%. Does that make sense? Right? So you don't want to lose the money you have. That's kind of messed up. So we use the money you have plus the interest. So the way you set up your equation here would be A is equal to 1,250, your initial amount, times the rate, which is 1.0475, to the power of T. Okay? So that's what's happening here.
Is it multiplicate 1 times 0.7?
1 plus 4.7. Yeah, 1 plus 0.0475. Because we're adding on to our original 100%. Right? So I guess I'll add that in there. So if you have a rate as a percentage, right? So this would be growth rate. And I'll give this formula as well. Okay. All right. And then it says estimate from the graph. Once again, you're not going to be graphing. So you don't have to worry too much about that. So honestly, the main thing I really cared about for question 2 is question 2A for you guys. If you did solve the rest of these here, you should be able to figure out how long it takes for the money to double, which means how long does it take until it hits 2,500.
Mr. Choi,
And then
would
we
we take the marks off if we did 1 plus 0.475? Like, which, or do we have to write it like this?
I would not mark you off for it. Just be careful when you do have to use the formula that, of course, you add them before you use it in a power. But otherwise, you wouldn't lose marks. All right. And then any questions on question 3 here, solving each equation for x here? So this did require you to use a scientific calculator if you had troubles with it. But like, for example, here, you would get x to the 14 divided by x to the 12 is going to give us x squared is equal to 225. And so how do you get rid of a square? You square root it. So you'd have to square root both sides. So this one here, when you square root both sides and you square root 225, we get x is equal to 15. If you forgot and you're like, I don't know what it could be, then you have to guess and check. Square roots, I think, are doable. So these were just pretty much figuring out, okay, do the exponent laws, then figure out what the base should be to make this all true. So if we do question C, for example, here, we multiply at the bottoms first. So we get x to the power of 24 divided by x to the power of 21, which gives us x to the power of 3 is equal to 125. So what would x be here? Well, if we cube root it, or if you were to type in a calculator, oh, what multiplies by itself 3 times to get 125? It would be 5. 5 times 5 times 5 is 125.
Why is it x cubed? Why do we do x cubed there?
Because 24 minus 21 is 3.
Oh, I see. Okay.
Yeah. Sorry, I missed the thing here. So give me 1 second. Let me fix that. Let me just redo this. So we get x to the 24 over x to the 21 equals 125, which gives us x cubed equals 125, which gives us x is equal to 5. And so that's the process. And then D is just overly complicated, right? But it's the same idea. You follow the same rules, right? And you should be able to get your answer. So what happens here? We can do this and this first, as well as here. These are all separate exponent laws that we can do all at once on the same step. So x to the power of 15 over x to the power of 5. And then we have on the next bracket, -3 minus -6 is x to the power of 3 to the power of -1. And what does -1 do? It flips it. So we get x to the power of 15 over x to the power of 5 times x to the power of -3 when we multiply it in first. And 15 divided by x to the power of 15 divided by x to the 5 is going to give us, I'm like running out of space. I wrote too big. X to the power of 10 times x to the power of -3, which equals 128. And then you can see where this goes. That should end up for us. I'm running out of space. I don't know how I'm going to write this out. I made a very poor decision on this. Okay, I'm just going to have to do this. Okay, and that gives us x to the power of 7 is equal to 128. And then you would have to figure out, oh, what to the power of 7 is 128? Which, once again, is easier on a scientific calculator, and I won't let you do this on an actual test, because I know some of you don't have this function on a calculator. Someone had a question? I think Brooks had the answer there. So x is equal to 2. Yes, that would be correct. Very good. Okay.
Yes, sir.
Anything else from part 1?
Yes, sir.
Yes.
How'd you get the 7?
10 and -3. When you add them together, we get x to the 7.
Okay.
Anyone else? Okay. So we are running a little bit short on time now. So we will continue tomorrow morning before the test. And some of these questions, so if you haven't done the half-life question, I highly suggest using this. Okay. Power of 5. Number 4, once again, too complicated for you guys. I'm not going to put this complicated of a question, I promise, on your test. Question 5, I think, is fair game with half-life. And so let's work with that there. And then we have more exponent law questions here, like question 6. This is fair game. Question 6 is fair game. This is completely doable. So 5, 6, everyone here should be able to do most of it. You do not have to do question C or D for question 5, though. Just do A and B. Okay, that's the thing I want you to worry about. And then question 7 is fair game as well. Question 7A and question 7B are both fair game. Okay. So these are the questions I'd like you to do before tomorrow. Of course, these are good questions to practice for tomorrow. It's like you have your word problem, you have your exponent laws, and then you have identification of growth decay, right? So make sure you do these, and then we're going to take it up tomorrow, as well as some of the textbook problems that you may have, questions that